All right, section 5.5, use inequalities in a triangle. So we are going to find possible side lengths of a triangle. So for our warm-up, we've got an inequality. We are just going to solve them. We are not going to graph them. On number 1, what would be my first step to solve? Subtract 8. Remember, we solve these very much like we solve equations. So 3x is less than 21. Then we would divide x is less than. Good. We won't worry about graphing that, but remember in Algebra 1 you did graph those on a number line, the open circle and the shading. Number 2, what would be your first step to solve? Add 9 is a good idea. Add 9 on both sides. That gives me 24 is greater than negative 2x. Very good. So we divide both sides by a negative 2, but we have to remember when we do that to flip our inequality symbol around. So instead of a greater than symbol, now it's a less than symbol. If you were to leave your answer there, that would be fine. If you wanted to move x over onto the left side, you would have to flip your symbol back around again. So either one of these works for me. All right, on number 3, what is the first thing we need to try to do? Okay, simplify by combining like terms on the right side. So 2x minus 2 can just stay the same. They put parentheses, but there's really nothing to distribute, so we can go ahead and ignore those parentheses. Take 3x plus x, we would get 4x. Negative 4 minus 8 is a negative 12. The next step to solve it, do what? Okay, we could add 2 to both sides, and we could also subtract 4x from both sides. Might as well do that at the same time. So 2x minus 4x, negative 2x. We're not flipping our sign right now because we did not multiply or divide by a negative. We just added and subtracted. On the other side, we would end up with negative 10. Now, last step to solve it. Divide by negative 2. And this time, what has to happen? Sign does need to flip around. Negative 10 divided by negative 2 is positive 5. Questions about number 3? Yes, ma'am. Anytime you multiply or divide both sides of an inequality by a negative number, the inequality symbol must flip. Anything else? Okay, number 4, find all integer solutions for 4 is less than x is less than 11. Anybody think they know one of the solutions? Ari? 5 would be one of them. Anybody else? 6, 7, and would we? 10, not 11. Would we include 11? Why not? Good. It doesn't have the equal to bar, so we do not include 4 or 11. Just those integers in between them. So they are numbers that are both greater than 4, because if we flipped this around, it would say x is greater than 4 and x is less than 11. Or just the integers in between 4 and 11. Questions on those warm-ups? Okay. On we go. Draw an obtuse triangle, labeling all the vertices. Name the largest angle, second largest angle, smallest, and then do the same for the sides. So we are just drawing some obtuse triangle, which means one of the angles needs to be greater than 90 degrees or bigger than 90. So if you just want to start out with your obtuse angle, and then you just need to connect your sides. I don't know that I'm super happy with mine. I might do this a little bit differently. There we go. I like that better. If two of your side lengths are too close in size, then your angles are going to be a little bit trickier to identify. Your triangle does not need to look exactly like mine, but for the sake of making this easier, we should label them the same way. What do you want to label your vertices? ABC? Yeah. It's usually one of the easier ways to go. So A, B, C. I would make sure you label the same vertices kind of the same way that I did if you drew your triangle like mine. So what is the largest angle? Okay, so angle A is the largest. What about the second largest? Angle B appears to be a little bit bigger than our smallest one, which would be angle C. That's our smallest. Okay, we were also asked to do the same thing for the sides. So what is my longest side? BC is the longest side. What about the second longest? AC. And what about the shortest? AB is the shortest side. Now, if you have not recognized some sort of relationship between the sides and the angles just yet, that's what we are about to talk about today. Okay, so this was just an exercise in labeling. You might notice there's some sort of relationship between the largest angle and the longest side. If not, let's talk about it. We have a theorem that states if one side of a triangle is longer than another side, the angle opposite the longer side is larger than the angle opposite the shorter side. So what that means in this diagram is that which angle is going to be bigger than which other angle? Good. Angle C in this case is going to be greater than angle A. Okay, because angle C is across from a longer side than angle A is. They didn't tell us anything about angle B, so we're not going to bring that into this situation. Similarly, if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. Yes? I hope so. Okay, so in this picture, which side is definitely longer than which other side? AB is definitely larger than side BC. Okay, because AB is across from a bigger angle than BC is. Biggest angle across from biggest side across from biggest angle, and it goes all the way down. So the smallest side will be across from the smallest angle. Works both ways. Questions about it? Okay. List the sides of triangle PQR in order from shortest to longest. Now, in order to do this most correctly, we need to know all three angles before we get started. Okay, right now we definitely know that PR is bigger than QP. Nope, PR is bigger than QR, but we don't really know how QP fits into that because we don't know angle R. Okay, so how could we find angle R? Sydney? Add them together and do what with 180? Good, add them together, subtract from 180. So if we take 80 plus 45, what do we get? 125, and then we take 180 minus the 125, we get 55. So that means angle R is 55 degrees. Now that we know that, we can do this problem based on the angle. So we are not doing this based on what the triangle looks like, because in my opinion, QP looks like the shortest side. But based on the angles, what's really the shortest side? QR, the one that's across from the smallest angle. So QR is the shortest. Which one belongs in the middle? PQ or QP. That one's across from the middle angle. 55 is in between 80 and 45. So our longest side is PR. That's the longest. Make sure you're paying attention to what order they ask for you to list these out in. Shortest to longest versus longest to shortest. It will change based on the problem, so just read the directions. Questions about example 1, Kobe?
How is QR shortest?
So we go based on the angles, not based on what it looks like. So based on the angles, QR is the one that's across from the smallest angle. So based on those theorems we did on the last slide, the one that's across from the smallest angle has to be the shortest side. Okay, does that make sense? All right. Other questions? Concerns? Moving on. All right, a boat makes a trip whose path has sides of 1.5 miles, 2 miles, and 2.5 miles long, angles of 90 degrees, about 53 degrees, and about 37 degrees. Sketch and label a diagram with the shortest side on the bottom and the right angle at the right. Now, in my opinion, that last statement is the most helpful when we get started. So I wouldn't start trying to sketch this until they kind of orient it for us. So we want our shortest side on the bottom. What should I label that side? What's the shortest length they gave us? 1.5. I know that I need a right angle at the right side of this. So on the right side, I'm going to go up with my right angle. And then I can just finish off my triangle. We can go ahead and put in our right angle box. And from here we can label everything else. So it doesn't really matter to me what you want to start with, sides or angles. If we've already got this side labeled, that's the smallest side. So across from that better be which angle?
37.
The 37 degrees. The smallest angle needs to be across from the smallest side, which means our last angle down at the bottom left needs to be labeled 53 degrees. That's the only one left. So then we just have to decide which side gets labeled with 2 miles and which one gets labeled with 2.5 miles. Any thoughts about how to make that decision? Atea?
Would the leg on this side, would that be 2.5 since it's across from 53? I
will disagree. Because 53 is not...
90.
Okay, good.
So it's on the hypotenuse.
Good. The hypotenuse needs to be the 2.5 because that's across from our biggest angle, which is 90 degrees. That leaves the 2 miles to go on the other side. Questions, concerns? We're all okay with this idea of matching up opposite sides and angles? Okay. Next theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so if we add up any two sides, for example, if we were to add AB plus BC, if we add those lengths together, it needs to be greater than AC. Technically, we can make these statements all the way around the triangle, meaning if we add AB plus AC, that needs to be greater than BC. Also, BC plus AC has to be greater than AB. Now, usually there's only one statement that makes a big difference to us, and that would be the first one that we wrote. The smaller two definitely need to be bigger than the longest side. If we were to know that AB is AC is the longest side, then of course adding it to a short side is still going to make it bigger than the smallest side. So some of these statements might seem kind of trivial sometimes, but the base idea of it is if you add any two sides, it better be bigger than the third side. Questions, concerns, need more time? Okay. A triangle has one side length of 14 and another side length of 10. Describe the possible lengths of the third side. So, this is the triangle inequality. So you could draw yourself some generic triangle, and as long as you don't get too attached to what it looks like, then it's not going to make a big difference. Sometimes I even just like to draw these as equilateral-ish looking triangles, just so that I don't get too attached to any sides being longer or shorter than the others. One side has a length of 14, the other has a length of 10. We are trying to figure out the possibilities for the third side. So, if we use those types of statements we made on the last slide, we could make statements like x plus 10 needs to be greater than 14. We could make a statement like x plus 14 needs to be bigger than 10, which of course that one is one of the ones that seems kind of silly. And we also can make a third statement that says 10 plus 14 has to be bigger than x.
Do we
So
have to do all three statements?
for starters, I would start off making all three of them, and then eventually you'll kind of get the hang of which one is silly to make. So of course, we already talked about it a little bit. This one's going to be silly to talk about because when we solve this, what would we end up with? A negative. Are we ever going to use a negative side length? No. So this is the one that we ignore. So when you get the hang of figuring out which one's kind of silly, no, you don't really need to make that one. You're going to be focusing on two of them. We do need to solve both of these though. So this one says that x would be greater than 4, and this one, well, the way it's written, it would be 24 is greater than x, but if we flip it around, x is less than 24. So we need both of these to be true. If you remember this from Algebra 1, this would be an AND inequality. So we need this one and this one to be true. And I'm fine if you write them out separate. If you really prefer to see them all put together, it would look like this, with x squished in the middle. Either way you want to write your answer, I'm fine with. If you want to leave them split up, not a big deal. If you want to squish them together, that's fine. So our possible side lengths would be any numbers in between 4 and 24. Questions, concerns about number 3? We're sure? Okay. Then let's talk about number 4. Describe the possible values of x. So again, one of our statements is going to be that 4x plus 2 plus 8 has to be bigger than 18. Now, using the one with the 18 and the 4x plus 2 together being bigger than 8, that's the silly one because 18 is already bigger than 8. So I'm not going to make that one. But the other one I need to make is that 18 plus 8 needs to be bigger than 4x plus 2. And from here, this is going to be similar to the last problem. We've just got more steps to solve. So for the first statement, the first thing I could do is combine like terms. 4x plus 10 is greater than 18, and then we would subtract. 4x is greater than 8. Last step is to divide. X is greater than 2. On the other one, again, we could combine the 18 and 8. 26 is greater than 4x plus 2. Then we would need to do what? Subtract. 24 is greater than 4x. Last step. Divide. 6 is greater than x, or you could rewrite it. X is less than 6. And again, if you really want to smush them together, you could do that. 2 is less than x is less than 6. Questions, concerns about setting up or solving these inequalities? Now, if you end up setting up the third one that ends up being kind of silly where you get a negative number, you can just ignore it and move on. You don't have to erase it. I'm not going to mark it wrong if you leave it there. So if you want to set up all 3 of them, just to make sure you can. Questions about 5.5? John. We divided by a positive 4, not a negative 4. So we're going to not switch it until we rearrange it. Does that make sense? Okay. Yes, ma'am.
So why'd you switch the other one?
I switched this one because I flipped the whole thing around. This one I didn't have to flip around. X was already on the left. If you want to leave X on the right, it doesn't make a huge difference to me. That's fine. I know in Algebra 1 we emphasize putting your variable on the left.